Okay, so on Friday, you were supposed to figure out the width of aluminum foil, and not everyone got to that, so we're gonna do it for homework tonight. Okay, so here's my aluminum foil, and what we know about it so far is, let me put this ruler on, we could calculate the width of the aluminum foil, and the width of the aluminum foil is about, let's see, it's about 5 point, well, it's right on that 5, so I'm gonna say 5.01 centimeters. So the width is 5.01 centimeters. My length is going to be, let me put it in place, 8.71. It's right on that 7, little past that 7 mark, 8.71. 8.71 centimeters. And we do know the density. If you look at the worksheet that we have been using all along, we can see that the density of aluminum is 2.7. It is 2.7 grams per centimeter cubed. So for every 1 centimeters cubed, we have 2.7 grams. And with this information, we can actually solve for the thickness. So I'm not gonna do all of it for you, but I'm gonna talk you through some of it. Oh, and we also need the mass. So here's our mass. Our mass, if we put it on the scale or the balance, is, this one was 0.18 grams. Okay. And what we're solving for, actually, for the thickness of aluminum foil, if this is the length and this is the width, the thickness is actually the height, how high it is. Some of you were a little confused on the worksheet with that. So just the height. Okay, so number one on the handout that you got, or some of you got on Friday, some periods didn't get to this at all. I want you to copy this. Number one, calculate the area of the foil. So right underneath, you're going to copy the question, calculate the area of the foil, and how would we calculate the area? Well, area is length times width, and that's the area. And because this is centimeters and this is centimeters, this is going to be centimeters squared. So you'll solve for that yourself, length and width. Copy down this question. From the mass and density, calculate the volume of the foil using a ratio. So what ratio can we get from density? Well, remember, we can rewrite this as a ratio and say for every 1 centimeters cubed, there are 2.7 grams. So your density will always be written as a ratio. And on this side, do we know the mass? Yep, we put it on the balance and it's 0.18 grams. And do we know the volume? No. So we're gonna solve for centimeters cubed. Now before you start, predict what kind of number we should see. This is 2.7, this is 1. This is smaller, 2.7 times smaller. So this also needs to be smaller, 2.71 smaller. So you have two options here. We could say 2.7 times 0.18, or we could do 2.7 divided by 0.18. Feel free to calculate both of those. And the one that gives you one that's 2.7 times smaller is correct. Then it says, from the volume of the area, determine the thickness of the aluminum foil, because volume equals area times height. So if we have volume, and that is equal to area times height, how do we solve for the height? Well, this is just arranging an equation. If we do the same thing to both sides, it will remain equal. So if we divide by area and divide by area, area cancels out on this side, and height equals volume divided by area. So the volume is from this one and the area is from this one. And because this volume is going to be centimeters cubed and the area is centimeters squared, our height is just going to be 3 minus 2, it's just going to be centimeters. You can figure that out yourself. Then it says, and copy down this question, why should we use a ruler? Well, actually just pause this and answer these questions. Pause this, write these questions down and answer them. The aluminum foil, this last question here, once you get these centimeters, if an atom, so we'll do a ratio here. On this side, it's telling you that one particle is, well, times 10 to the negative 8. So 2.9 times 10 to the negative 8 centimeters. Then you will put your number here, down here, and you are going to solve for the number of particles, basically. So look at this. Which number is bigger? Well, this number is bigger. To the negative 8 would be if we move this over 7 times. It'd be 1, 2, 3, 4, 5, 6, 7, 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, if you know scientific notation. This is way smaller than this number. So again, this number should be bigger than this number that you get. And it should be this many times bigger. I will let you guys answer these questions for 1, 2, and 3. Do the best that you can, and tomorrow I will put up a key so you can check your answers, because I'm not sure we'll have time to check answers tomorrow. We'll see.